I'm thrilled to introduce today's speaker, Aaron Kaufman, who's an assistant professor of political science at New York University Abu Dhabi and an affiliated assistant professor of politics and data science at New York University. He received his PhD in government in 2019 from Harvard University. Thank you so much for joining us today, Aaron.
Thank you very much. It is a pleasure to be here. As Allison mentioned, my name is Aaron Kaufman. I am at NYU Abu Dhabi. And today I'm going to be talking about the American presidency. And a lot of this work is going to come from a book project that I've been working on with my co-author, John Rogowski, at the University of Chicago. And this book and the papers that are associated with it introduce some text as data approaches to studying the American presidency. So today I'm going to talk about some of the data that we've assembled, some of the methods that we employ, but I'll also hope to give you some fun historical flavor, talk about some of the empirical results. And in particular, the results I want to focus on today are about how presidential power operates in systems of divided government. So I'm going to motivate this with what John and I have started to think about as the paradox of presidential power. On the one hand, we have Richard Neustadt, the dean of presidency scholarship, noting that everybody now expects the man inside the White House to do something about everything. That is, different constituencies expect the president to manage the economy, to maintain world peace, to fight for the little guy, to enrich their corporate backers, to conserve the environment, to protect jobs. And then on the other hand, there's an entire system of governance that seems stacked against the president. The president has extremely weak formal powers, that is, mostly the veto, but also some leeway with international affairs and tariffs. And there are two other branches of government with just much more constitutional capacity to check or to overturn the president's actions. As well, we have a series of de facto constraints, things like polarization, gridlock, and just plain old obstructionism that keep presidents from successfully motivating their party members to actually get stuff done. So how do presidents manage to thread this needle? How do they maintain their popular support, keep their constituencies together, and pass their agendas despite having the deck seemingly stacked against them? Now, there's quite a lot of empirical work on this topic, and the consensus is generally that they don't. At least not anymore. So here's a representative figure from the literature taken from Alex Bolton and Charisse Thrower's 2014 AJPS paper about this topic and presidential power. They find that in the old days, that is, up until the end of World War I, presidents generally could use their unilateral powers to solve this debate. That is, on the left-hand side, we see that in this period, presidents tend to use more executive orders during periods of divided government. That is, when one or both chambers of Congress are controlled by the opposite party. And so when the government was divided, presidents could use executive orders to get the policies they wanted, even when Congress wouldn't do it. But starting in the post-war period, that's no longer true. Presidents appear in this period to use fewer executive orders when the government is divided. That's the right-hand side of this plot. So this raises an important question. Why is it that modern presidents seem to use executive orders less under divided government, despite the growing sense that Congress is weaker than ever, that modern presidents are stronger than ever, that gridlock and polarization are deeper than ever? And the literature proposes something of a post hoc theory. And this post hoc theory is basically that presidents are afraid of getting overturned. That if a president issues some kind of action, engages in some kind of policy, and Congress then overturns them, this harms their reputation, saps their political capital. But frankly, no one really buys this argument. They just don't really know what to do with the evidence at hand. So this is where we come in. We're going to resolve this dilemma by introducing a new comprehensive data set of presidential orders first. Then we're going to build a series of text-based computational models to machine code each of these orders for their topic as per the Comparative Agendas project, and for their substantive significance, which I'll get more into in a bit. And then we're going to show you some new results along the way. So to be a little bit more specific, we're going to get more than 100,000 documents, signed presidential orders, mandating some kind of new policy across 50 different types of directives, expanding far beyond the typical one type of order, executive orders, that most scholarship tends to study. Then we're going to measure topic area using Comparative Agendas project scores. and we're going to measure significance by leveraging Chu and Rothenberg scores. And I'll explain more about how this machine coding works in just a little bit. Then the new results I want to talk about today. First, presidents are strategic about what types of orders they use. When do you use an executive order versus a proclamation versus a memo versus some other type of article? When do presidents use one versus the other to get their policies across? And I'm going to show that this is strategic and has some logic to it. Next, we're going to resolve the debate I started with by noting that presidents tend to issue more orders under divided government, not fewer, even in the modern era, contra Bolton and Thrower. And to do that, I want to start by this neat little historical case study that I think is really fun. So presidents have always had a suite of unilateral tools at their disposal. They have executive orders, which are the most well-known, but they're not the only one. And interestingly, these tools all seem to be mostly legally interchangeable. They all have equal force of law. They all have equal constitutional grounding. And with some narrow exceptions, most of them can address any area of policy. Then, in 1935, something strange happened. There was a pair of high-profile Supreme Court cases related to petroleum production and taxes, where upon deciding the case, it was actually discovered that the federal regulation being debated did not exist. As it happened, the provision under consideration had been originally announced as part of a unilateral action, but due to a printing error, it actually didn't make it into the final version of the order, and so it didn't technically exist. So to figure out this discrepancy, it just took far more legwork than should have been the case. And the Supreme Court justices were very angry that they had wasted their time. And Congress was upset that the executive branch had passed so many of these things that no one could even keep track of them all. So to remedy the situation, Congress drafted what was called the Federal Register Act. This act was explicitly designed to monitor and to constrain the president. And the way it did so was by establishing an official publication that was responsible for printing all federal regulations and executive orders, and for which it was immediately disseminated to newsrooms around the country. Now, notice I said executive orders and not unilateral actions. And this is because only executive orders were subject to this law, which had the inadvertent effect of taking the president's more than 50 different unilateral tools and making them distinct. Now, there's one set of tools, which are broadly called executive orders, for which the presidents can kind of do whatever they want, and they know that they're going to get published in the Federal Register. And then another set of tools that no one really knows to look for, and they might be obscured because there's one source people know to look for unilateral actions, and it's not that one. So in sum, 1935, the Federal Register Act, it produced two sets of tools. Executive orders automatically sent to newsrooms. Everything else not automatically sent to newsrooms. And due to the coverage of executive orders, those kind of maintained the shroud of secrecy. So what happened? This red line here shows the yearly total of executive orders from 1880 to 2020. This is broadly the set of documents that all existing scholarship on the presidency drew us from, including the Bolton and Thrower figure I showed you earlier. Now, this black line here is the set of all unilateral actions. And we can see that they tend to track pretty closely. The black line is always above the red line, but in some cases, the gap tends to be smaller. But starting in about the 50s, they began to diverge. And then by the 70s, there was quite a big gap. So what fills this gap? Documents that we're going to class together as presidential memoranda in blue, and then proclamations in green. And this gray dashed line here down the middle, that's going to be the dividing line between Bolton and Thrower's two plots. Left of that, we have a high correlation between executive orders and the total number of orders. And in that regime, divided government produces more unilateral action. Right of that gray line, where they diverge, we observe the opposite relationship. And I think you can probably tell where we're going with this at this point. We can observe this relationship. We might suspect that presidents are doing all of their important but unpopular stuff as memos or proclamations, these less visible types of orders. And they're doing all of their important and popular, or just their kind of more ceremonial things as executive orders. People get to see only the popular or the harmless stuff, and then interest groups get to see the pork, the kickbacks, all the hidden stuff in the unpublished orders. So to test this, we need some way to distinguish these documents on a little more granular level, which I'll get to now. Now, a long history of presidential scholars have noted that not all orders are created equal. Some unilateral actions do things like freeing the slaves or interning all of the Japanese during World War II, whereas others do things like establish National Ice Cream Day or officially honor Dolly Parton. And now the old school approach to this would be to just hand code everything. That is, we hire a small army of research assistants and have them read thousands of documents and manually say, this one's Dolly Parton Day and this one's freeing the slaves. But there are just too many documents for us to do that realistically. So we have to turn to different approaches. Now, Howell kind of revolutionized this field in 2003 by using newspaper mentions. The idea here is that an executive order that's mentioned on the front page of a major newspaper is probably pretty important. And this takes a lot of time to hand code still, but it's at least a little bit more rigorous. On the other hand, in some ways, it's not a very good proxy. That is, there are lots of important orders that don't get any of attention, especially if they're not executive orders. And there are many unimportant orders that actually will get a lot of attention just because they signal something important about the presidency, or maybe they mark a shift in priorities, even if they don't actually change any policy. So Chu and Rothenberg solved this problem a little bit in their 2014 paper, where they extend Howell's approach beyond just newspaper mentions. They take newspaper mentions as well as more than 20 other factors and put an item response model on top of this to basically get a more sophisticated measure of significant versus ceremonial documents. But this is even harder to hand code. And so though it's a better proxy, it more accurately measures significant versus ceremonial orders, it's still not very scalable. And that's not going to work for our more than 100,000 documents. So our solution, which I've hinted at the beginning, is that we're going to train a text-based model. That is, Chu and Rothenberg have measures for about 10% of the 100,000 documents in our sample. And we're going to use Chu and Rothenberg's scores as a training set. And then we're going to build a model to learn the relationship between the words used in a unilateral action and Chu and Rothenberg scores. So what words in an executive order tend to predict being significant as per Chu and Rothenberg, and what words tend to predict being ceremonial? Words like mandate or enact or enforce tend to be words that indicate significance. Words like celebrate or honor, those tend to predict ceremonial. And of course, there are many other words into these categories. And our goal is to discover these words automatically and their higher level interactions. So the model that we're going to use is a random forest trained on unigrams through trigrams, that is, single words through sequences of 3 words. And then in cases where the random forest model is a little bit conflicted or is not quite sure, we're going to hand code additional examples. This helps us ensure that our model is trained on the edge cases accurately, but it also helps us validate this model forward and backward in time. Chu and Rothenberg only label measures in a certain time period, and if we'd like to expand that forward from 2014 to 2022 or backward to the beginning of the presidency, it helps to have additional training examples. Overall, our accuracy is really high. AUC is the standard way of measuring this, which is called the area under the receiver operator characteristic. It's a standard measure of predictive accuracy in these kinds of machine learning applications, and it ranges from 0 to 1, where 0.5 is random chance in the case of a binary classification setting. Generally, 0.7 is considered passable, and our AUC is more than 0.9, which is higher than any of the 3 research assistants that we hired to do this hand coding. And it's also higher than the aggregation of all 3, which is 0.71. So in short, our model does a very good job at predicting Chu and Rothenberg scores based on the text of an order. And we include tons of robustness checks to ensure that we're doing this well, including to make sure that our scores are accurate in previous time periods and in later time periods, and that they're accurate for all presidents roughly equally. And I'm not going to talk much about our topic classifier, but because the topic classifier works essentially the same way, that is, we use comparative agendas project labels to train a random forest model. We're going to hand code it in the same way. We're going to validate it in the same way. We're going to conduct the same robustness checks. The only difference is that we're going to use a synthetic rebalancing approach to deal with the fact that there are some topics that show up a lot more and some topics that show up a lot less. I'm happy to talk more about these things in Q&A if anybody's interested. But let's get to the meat of the talk. Let's see what the juice is from this squeeze. So the light gray line here, that's the count of non-ceremonial executive orders as per Bolton and Thrower. In other words, these are the things that they're studying in their data set. Now, this dotted line down at the bottom, this is the count of significant executive orders that Howell finds in his 2003 study, which is a lot less. The black line is the count of total significant orders as per our measure. And you can see some quite big differences here. We find way fewer non-ceremonial orders in kind of the earlier period. And we find way more in the later period. We document quite a strong secular uptrend since essentially the 1920s in significant directives. Whereas we can see that Bolton and Thrower document quite a significant decrease from the World War II period. So what this tells us is that if you're using one of these measures versus the other, you're going to get really different results when you put the counts of these orders into a standard kind of regression framework. And just for comparison, here is the count of significant legislation as produced by two different measures. On the left, we have Ensala-Beher, Palmer, and Schneer, 2018, giving the count of significant legislation per year from 1877 to 2010. And on the right, we have a Clinton and Lipinski 2006 measure of roughly the same thing. And in both cases, we see that the variation is relatively small. Ensala-Beher, Palmer, and Schneer go from 0 to roughly 20. And the increase in the post-war period is roughly double. Clinton and Lipinski, similar increase in the post-war period is roughly double. But we find orders in the post-war period, which were in the 20s to 50s, increasing roughly into the 200s. So we find that executive orders, proclamations, memos, unilateral actions in general are increasing at a much greater rate than significant legislation. And this is especially true compared to Supreme Court opinions, which are just a straight downtrend. The Supreme Court is doing less and less and less nearly every year. So I want to have two short slides with some descriptive results about some of the empirical tests that I mentioned earlier, and then I'm going to open this up for questions. And this first slide is going to be about strategic substitution. I'm going to show you 5 regressions where the unit of analysis is the order, that is one unilateral action, and the outcome is whether that order is issued as a memorandum, as an executive order, something else. And if the story I've been telling is right, then under divided government, we expect that presidents are going to be more likely to issue their orders as memoranda rather than as executive orders. And we're going to see that across all 5 model specifications. In the last specification, we also see that the more popular a president is, the more likely he is to use his directive, to issue directives as an executive order, even controlling for divided government. And we talk much more about this part of the story in the book. So the coefficients here under divided government, this is issuing the executive order, or issuing as an executive order. And a negative coefficient here indicates that as you switch from unified government to divided government, you are less likely to issue the order as an executive order and more likely to issue it as a proclamation. And this final result slide goes back to the early motivating question of whether presidents issue more orders in general during divided government. We run 4 regressions this time where the unit of analysis is the year. And in this case, we're trying to predict the number of significant orders each year based on whether the country is under divided government or unified government, plus a whole bunch of controls and fixed effects. At the bottom, we have the result considering only significant executive orders. That is, this regression has the count of significant executive orders on the left-hand side and has divided government plus controls on the right-hand side. We can see that the coefficient on divided government is negative and not really statistically significant, nearly perfectly mirroring Bolton and Thrower's figure at the start. So here, using our new measures of executive order significance, we've replicated the Bolton and Thrower finding from 2014. But when we consider the count of significant proclamations, or memoranda, or of all documents taken together, we see a consistently positive and often statistically significant relationship here. That is, this is what we would expect to see if presidents are more concerned with passing their agendas and maintaining popular support than they are of being checked by Congress. In other words, under divided government, presidents are going to issue more significant orders per year than they will under divided government. So I'm running low on time, and I want to wrap up really quickly. So in this book, we're mostly going to study presidential unilateralism. And we're going to show that there's a massive selection bias caused by only studying executive orders, which are a strategically selected subset of all total orders. We remedy this by assembling a new data set, an exhaustive data set of presidential orders, and measuring them all with a text model. Our payoff for this is the sensible but previously rejected hypothesis that, in fact, presidents do care more about passing policy than they are afraid of being checked by Congress, and they're more likely to issue more unilateral actions when Congress is divided or against them. This is one of the earlier chapters in our book manuscript. Other chapters are going to address things like congressional and judicial oversight, presidential control of the bureaucracy, how public opinion and issue salience affect which topics presidents tend to address. And we're going to include case studies on the early environmental movement, on lobbyists, and along the way, lots of colorful history about interesting moments in presidential governance and lots of colorful characters. So that's all I have for today. Thanks very much for your attention. And please feel free to reach out with any questions or comments.
Okay. Well, I'm waiting for others. I'm really interested in the process of doing the data collection and the assembly of the data set, because that seems like a monumental task, especially for non-published orders. Can you get a little bit into the weeds of, were you using Freedom of Information Acts? How are you assembling that?
Right. So just because an order isn't published in the Federal Register doesn't cease to exist. A lot of these documents are found in other collections, in archives, or in libraries. And a lot of these have been compiled by other various sources. In particular, there's a record called the CIS Index to Presidential Orders and Proclamations, which has non-transcribed versions of all or nearly all of these documents. So we collect all of these PDFs, we machine transcribe all of them. Ones that don't machine transcribe very well, we manually transcribe. That is, we have to extract the text for these. A lot of these are handwritten in cursive. A lot of them are typed up on old typewriters with things crossed out. And so, yes, the process was quite laborious. It was a lot of work to assemble this data set, but we think it was more than worth it. And the data set is now fully available online as part of our replication materials for both of our papers. We're going to continue to expand this data set every year. We add the previous year's unilateral actions, retrain our model, rerun our model. And we're working on extending this data set beyond just presidential orders to include federal rules and regulations. There are already data sets like this to study public laws, court decisions. Eventually, we'd like to produce a large public repository of all federal policymaking documents with a series of machine-coded scores associated with them.
Thank you. It's always really exciting to hear of researchers investing significantly in the building of an open data sources. And, one of the tensions that, of course, comes up in the careers of faculty is, will that be worth it in terms of your own publications, and then in terms of doing this sort of public good and how that's seen? I'm curious about the early decision making of, okay, we're going to be the ones to do this.
Sure. So I totally hear you that it's not necessarily always worth it to produce public goods, but I think the calculus has to depend on how valuable you think the public good is. There are a lot of people who invest in public goods because perhaps they're a little bit too deep into a subfield and don't understand and kind of overestimate how broadly significant that public good will be. I've been guilty of this before. But there are other times that you see a public good and you think, no, if I produce this, hundreds of people are going to use this and it's going to be worth it. And the philosophy of publications that I'm increasingly converging on is, a home run is worth more than 4 singles. And so producing a paper that fundamentally reworks existing wisdom, introduces new methodological approaches to a subfield, produces a public goods data set all at the same time, and potentially contributes to multiple of our own projects, I think that's more than worth it. And I should say, by the way, there are way more paper ideas that come out of this data set than my co-author or I could ever possibly get to on our own. We have no shortage of analyses we'd like to do with this data set. And this isn't the only data set we've compiled. It's not even the only data set we've compiled of this scope. So we have essentially no way to do everything that we'd like to do with this data set. And so we don't really see any harm in completely open sourcing it and letting anybody who wants to use it.
Thank you. There's a question from Stephanie asking you to walk through the process of analysis in a bit more depth. Sort of what are the steps of setting up a random forest model? I know you did some regressions. I'm assuming those were post hoc after the random forest. You can sort of talk through the order and steps in the process.
Sure. So we go through this very slowly in the paper because the presidency literature tends to be a little bit old school in terms of the sets of methods that are allowable. And so our goal in the paper, which I definitely encourage you to take a look at for more detail, is to serve as sort of a pedagogical example for this subfield. But in short, the way that it's going to work is, you assemble a big data set with a y variable and a bunch of x variables, the same way you would for any other standard data analysis. In this case, the y variable, our outcome, is going to be Chu and Rothenberg scores. And Chu and Rothenberg scores are associated with executive orders, and executive orders are all neatly identified. They have a number, executive order 12866 or something like that. And then we're going to link that executive order number with the raw text of the executive order, which we're going to pull from PDFs. But it's not necessary to pull them from PDFs. They're available pretty regularly online. Then what we're going to do is we're going to take this text and we're going to do a very light amount of pre-processing. In particular, we're going to convert it into what are called unigrams and trigrams, which this process is called tokenization. And so a unigram is just any single word. A bigram is any pair of words. Do not is a bigram. Executive order is a bigram. And trigrams, which are any 3 words. And then each document is going to be represented as a count of unigrams, bigrams, and trigrams. So we take all of our 100,000 documents, we find every single possible unigram, bigram, and trigram in these documents, and then every document is represented as the count of all of these. So that's going to be way, way, way many variables. That's called our vocabulary. And most of these are going to be zeros. Most documents are not going to mention every single word. Most bigrams and trigrams are only going to be mentioned in a small number of documents. And so it's typical to remove some of these, remove either bigrams and trigrams and unigrams that every document uses. Doesn't really matter how many times a document has the word the or of or an. And you're also going to remove very rare ones. If fewer than maybe 0.1% of the documents mention something, it might be informative, but maybe not super informative, and maybe not for a large number of documents. So you remove those until you have maybe 5,000 to 10,000 different unigrams, bigrams, and trigrams in your vocabulary. And then once you have that, it's a standard tabular data set, just like any other standard tabular data set. And you can run any form of regression on it that you'd like. We use a random forest because random forests tend to do well in these types of tasks. That's just kind of folk wisdom. And then most random forest methods, and especially most R packages these days, include built-in diagnostic tools to measure their accuracy. And we're just going to rely on those. We build our own diagnostic tools for some of the robustness tests, but those are maybe a little bit beyond the scope of that question. I hope I did a good job answering, and if not, feel free to reach out more. We can talk about it some other time.
Okay, any other questions? I'll just make a quick note that sometimes I think particularly graduate students are kind of surprised at how reasonable the coding is for machine learning methods, including random forests. And so I know you noted that you have your replication files. And so if you have an opportunity, take a look at the actual code. I think it's always really helpful to see what that looks like if you're thinking about doing a machine learning process, because often it can seem really daunting until you actually start getting into the process. I don't know if you want to add
just these tools are very usable these days, especially in R.
And I'll just also throw in ICPSR has a fabulous machine learning class that goes into all of this really well. Is there anything that you tend to tell your graduate students who are interested in working with machine learning approaches, but are maybe a bit nervous?
I think that's a good question. I think there's no substitute for just trying things and struggling through them. You know, there's an important stage in a graduate student's career where they struggle with coding, struggle with modeling, fail a lot, and eventually succeed. And as long as it doesn't take too much time in failing, and as long as they do eventually succeed, then it's a really important confidence builder. It's important for graduate students to get the confidence that, you know, I can learn about some new tool, and if I really apply myself, yes, I can read the paper and I can figure out what the math means, and I can implement it on my own, and I can get this model to work. It might take a while, but I know that I can do it. So I think struggling through these things and figuring them out, totally worthwhile. And if the current tools are more developed and easier to use and more user friendly, then the more cutting edge tools still won't be. So it's still quite easy to use off the shelf, for example, large language models in political science research, but kind of more cutting edge models are not quite so user friendly. And so struggling with those is something that I see a lot of graduate students working with now.
Yeah, I see that too. And being able to assess sort of what is the right model, what is the right package, what are the limitations of each, how do you make those decisions?
Yeah. I mean, generally, starting with a replication is the best approach. Start with somebody else's replication file. If you can't get it to work, that's their problem, but generally these days you should be able to get it to work. And then trying things on your own, swapping in your own data set into somebody else's replication or data pipeline, very effective for learning.